Welcome to Statistics for Surveys, Session 3, Diagrams for a Single Variable, Segment 4, Bar Chart. Here's a picture of a bar chart. As you can see in this bar chart, we can tell that slightly above 350 people are clerical workers, around 75 are managers, and somewhat about 25 are custodial workers. One probable definition of a bar chart is given by the APA Dictionary of Statistics and Research Methods, which says a graph in which bars of varying height with spaces between them are used to display data for variables defined by qualities or categories. A few things to notice. First up, there are gaps between the bars. This is usually done to emphasize actually that it's a discrete variable. So when you have a nominal variable or often also an ordinal variable, but also sometimes a scale variable. If you're counting things, it can be actually discrete. So here we have a gap between clerical and manager and a gap between manager and custodial. The next thing to notice is that the width of the bars can be chosen at random. However, the width of each bar should be exactly the same. Now the Oxford Dictionary actually stipulates that the width of the bar should not be the same as the width of the gaps, but I've not found any other reference for this. The third and last thing to notice is that the vertical axis can be any type of frequency, so either absolute frequency, relative frequency, cumulative relative frequency, inverse cumulative frequencies, and inverse cumulative relative frequencies, but not the frequency densities. These 3 points will actually be different for a histogram, so that's why I'm mentioning them actually now. When creating or reading a bar chart, there are a few things to look out for, and I'll give a few actually pointers to this by using an example. Here are 4 bar charts, 4 different versions, all actually coming from the same data. Now, in version 1, as you might notice, the differences between each of the bars, it goes up a lot and then it goes down a lot. So there seems to be somewhat of fluctuations going on. Well, in version 2, it actually goes up a little bit and a little bit down, but it seems a lot more stable. This is because the first version actually starts the vertical scale at 20, while the second version starts at 0. Now some say you should always therefore start at 0 because otherwise it can be misleading, as was done by Huff in How to Lie with Statistics. But recently most people actually agree that it can sometimes be actually useful to not start at 0. For example, even if small changes are actually important, for example at the stock market, then not starting at 0 is actually even sometimes recommended. Now, if you don't start at 0, I would recommend to use somewhat of a squiggly sign somewhere at the vertical axis just to highlight, so that here actually you do something like that in between on the axis, so actually to highlight that it doesn't start at 0. So when you're reading a chart, always check if the vertical axis starts at 0 or not. Now, if it doesn't, it's not wrong, it's just that smaller differences will become, might appear then bigger. Now in version 3, the graph seems to be going up, while in version 4, the graph seems to be going down. This is simply due to the fact that the version 3 is using cumulative sales in this case, and the version 4 is using the inverse cumulative. So cumulative usually tends to always go up because you keep on adding things. And inverse cumulative appears to be going down because you're actually subtracting things. So normally a cumulative diagram will actually appear to be going up. Doesn't have to be cumulative. Sometimes the sales really go up each year. That would be great, but always be careful if you see a graph that's going up, whether or not they're using cumulative or not. So far I've drawn all the bars going up, so vertical, and this is actually also recommended by Singh. However, sometimes you might have such long labels that it might be easier to actually put them all horizontal. One of the very first bar charts ever found is actually being used as a bar chart for descriptive statistics. Comes from William Playfair, and as you can see here, the bars are placed horizontal. It's not actually the oldest one. There's also one from Oresme from 1486, but that's more a theoretical concept rather than applying it for descriptive statistics. So my pointers when drawing a bar chart would be to label the vertical axis, or actually check what the vertical axis represents. Use a squiggle if you don't start the vertical axis at 0, or if you're reading one, check where it actually starts. Use vertical bars unless labels are very long. And I also came across something known as the 3/4 high rule from Pitt, which actually mentions that the y-axis should be about 3/4 of the length of the horizontal x-axis, or the maximum should be 3/4. So if the horizontal axis is 20 centimeters, the vertical axis should be about 3/4 of 20, it's 15 centimeters.